Hello everybody, welcome to this sim4nexus game tutorial. So you are in front of the browser, you have accessed the right page and you're in the Chrome web browser. And the Chrome web browser is actually the best browser to play the game. You could also try to play it via Firefox, so it's not as fast. So Chrome is recommended, whatever your machine is. You also recommended to use a mouse if you can, because then it's a lot easier to use the interface. If you don't have a mouse, you can still use keyboards and touchpad mixed together. The game is recommended for laptops or computer screens. It is not designed for tablets or otherwise mobile phones. All right, so you're in front of the screen here. You can click as play as guest, for example. It's recommended to actually sign in so that once you play, your profile remember the kind of scores you've played, and then it's added. Whatever you've played is added to the table of ranking. So once you have clicked and accessed the game, you're in this page, and you can select which country you want to play the game, and only a few countries are actually implemented. So we got Azerbaijan here, which is the simplest model we got. Then we got Greece, which is our most complex one, and we got the Netherlands just right here. So just for a start, I'm gonna have a look on Greece as an introduction. When you go to the Greek case study, we are gonna play the sim4nexus game on normal mode for the Greek case study. In normal mode, you have unlimited budget. You don't have any constraint about how much game money you can use or how much social costs you can use as well. Note that there is a policymakers mode in which every round that you can apply different policies, you are constrained by how much resources you can devote, and therefore how many policies you can apply at the same time. But we're gonna look at the normal game mode. So let's click play. You get a questionnaire that appears. You can click skip unless you participate to an experiment in which we would measure the difference induced by playing the game in the way you answer questions about the problem before playing the game and after. But let's click on skip, and we should be redirected to the game. It takes a few seconds to load. It's quite a complex model, quite a big model for Greece, around 11,000 variables, all interacting together. So now the first thing that appears is this window with information about the game. So you're really encouraged to read that because it tells you about the goals of the game and also introduce the context for Greece. Also gives you a couple of questions which show you what to look for while you play the game, things to identify, problems to see about the Nexus. And finally, there is around the end a list of controls for the computer. This game is made for computers, desktops or laptops, but it is not designed for things like tablets or mobile phones. One more thing is, if you want to see the controls and the introduction again, there is a little checkbox written control at the top right. You click on it and you have it again. And you close, click on it, have it again whenever you need it. The game has been designed to work really well with mouse. So if you do have a mouse, it's recommended to use one. You can pan the view by right-clicking and dragging the mouse while you keep your right-click button pressed. Or you can zoom in or zoom out with your mouse wheel, so you can see things in greater detail or have an overview when you zoom out. This will prove useful later in the detailed view of the game, because what you're seeing at the start is a normal view, but if you want a detailed view in which you can analyze everything, you click on the detailed view button on the top right, click on it, and suddenly you've got a lot of things happening and visible, and you can start inferring a lot more things. But let's get back to the simplified view that you need you only need that one to play the game in its simplest form. So the Chrome browser is recommended. There is compatibility with Firefox, but it's just better with Chrome, whatever the platform you use is. The screen as it appears divided in these 4 different views. So you got the game score, in which you got the Nexus health. The goal of the game is usually to maximize your Nexus health, which is the average of the different health bars of the Nexus. So the water health, energy health, food health, and climate health. So you're gonna spend a few years, there's this timeline from 2020 to 2050. You will drag and drop different policy cards, and every 5 years you click next turn, and you'll get to the next 5 years, and so on until you reach the end. And the goal is to maximize your Nexus health, and if possible, minimize the amount of resources you'll spend applying policies. So policies themselves are visible here. You've got water policies here, energy policies, land policies, food, climate. If you want to know more about a policy, just right click on it. The cursor takes the shape of a little hand, and when you right click, you got a window of information telling you more about what this policy is. This principle holds for other elements in the game, such as, for example, here, if you right click on the health bar for water, then it gives you a graph telling where you are in blue, and the gray line is the business as usual trajectory until 2050 if you don't apply any policies. Note that finally we got the other components here, the strategy map. So it represents for each one of the 14 regions of Greece different kind of scores, different things you want to identify. Here it's about the emissions for climate. So the 2 regions, unsurprisingly, which have the most emissions are the very industrialized region of Western Macedonia and Attica, which has the main town, Athens. If you can also view other aspects. If you click on water, you will see water stress per region. Energy, you see energy demand. The darker, the more intense. Land, you'll see some sort of measure of land stress or ecosystem stress. Here you will see food production. You have also an overview. So if you click on the overview button, you also see the population projected. So if we get back to climate here, notice that here, if you have the toggle map button at the bottom, you click on it and it changes the view to a more geographic kind of view. You can click back to the game-ish board view, which is more convenient for reading information. There is also a view crops button, which is quite important. If you click on it, it will show you for the whole of Greece, for all 14 regions, the surface of irrigated and non-irrigated crops, and it will show you the biggest square represent the biggest surface area for each type of crop. So for example, Thessaly in cotton, so for the crop of cotton, Thessaly is a region which has the most surface of cotton irrigated crops. And that means that if you were to apply a policy to save a lot of water, you could potentially apply a policy that replace irrigated cotton crop surfaces by a non-irrigated crop like olives, for example. And that would save you a lot of water for Thessaly, and you can identify which other region use a lot of irrigated types of crops and replace it by something else. Note that you can select, each region's got different health, Nexus health, and whatever you do to one region has an effect to the other regions around, because they're linked to each other, they have an effect, right? So if you click on, by default you start on Western Peloponnese at the bottom left, but if you click on, I'm going to zoom out slightly so you can see, on Western Macedonia at the top, then you will see your Nexus health change because this region is different, and whatever region you've clicked on, the policies you're going to apply to it are going to only be applied to the region you are clicked on at the moment. for example, if I want to apply to Western Macedonia some sort of energy policy, let's say wind electricity policy, then you will drag and drop this card at the top, and then it gives you a message. Do you want to apply this policy? It's going to cost you some sort of resources. You confirm, and then you'll see the gray area represent the time it takes for the policy to be built. And when the color is full, all yellow in this case, it will tell you when the policy is actually effectively working. Because some policies are effective immediately, but some others are not. It takes a while for it to be ready. So let's say some policies are not accessible at the regional level, only at the national level, particularly climate policies. So if I go to the climate type of policies, you see there's nothing if I have a region selected, but if I go to the national level, then some policies for climate emission, the reduction of greenhouse gas emission, are suddenly available at the national level. So I could apply a policy for zero emission or emission reduction, let's say here, drag and drop it, and it's going to do it at the national level over all 14 regions. That's why you see 14 different rectangles, one for each region. And if you right click, you will have a detail of what this policy is and which region is applied to. So you click next turn, and what will happen is the result, the model, the system dynamic model, which lives somewhere on a server in Europe, will compute the result of your actions. And so far nothing happens because the policies are not active yet in the case of energy and climate, still the gray area, the time it takes to build them. So you click next turn again, and then you will start getting some sort of effect for energy, while for climate you will probably need to wait a little bit longer. So I click next turn, and then what happens is you would see something going all up and all down. So you can see we have applied these climate policies, and your climate nexus health is going up because as a result of all these emission reduction policies, you got some sort of effect. Note that our energy health for the whole of Greece tend to go down because you only apply one small wind energy policy for only one region, so it might not have a massive impact, but that's for you to try and experiment with when you play the game. Another aspect of it is that when you see this curve represents your overall nexus health, the average of all the other nexus health, the different rainbow bars. If you right click on this rainbow bar, you can see the score, and the gray bar is the business as usual bar, showing you what would have happened if you hadn't done anything about it. But for example, in climate, you're going up compared to what would have happened if you haven't done anything. And notice that if you click on water, it will show you how presently your nexus health for water is calculated. It's based, you can right click to get information about the different policy goals and policy objectives which are used to derive your nexus health. So I right click and I get more information about the formula and what the scores are and so on. So for example, for climate, here you can see that the policy goal of reduction of greenhouse gas emission is based on the average of two policy objectives, O3 and O4. Same for reduction for 2030. And if I click on O3, then I have a detail what O3 is about. So let's go back here. This is our overview. So you've kind of played the game so far a few rounds. You've got to go to 2050 to finish. But this is not all the interfaces that are here. If you click the detailed view, then you will see a lot more happening. So I'm going to select a region, and you will notice that this little view here, called analytic view, provides you some sort of graph for if you're in the climate part of the strategic map when you select a region, showing you that for Western Macedonia, most of the emissions seem to be, if I click on fuel emissions, seem to be mostly ETS-based emission. Well, if I go to Attica, we notice that most of the emissions for Attica are non-ETS based. So that means that if you apply a policy for non-ETS reduction of emission, it will be more efficient to apply it to the region of Attica, and the other type for ETS emission would be more efficient in the case of Western Macedonia. And the same principle apply for different policies for different areas. So if I click on land or food, for example, you can see the type of crops, or for, let's say, water. If you look into the different composition per region, you notice there are different things going on, and you can go back up and analyze things a little bit. So that's for that view. That other view here contains a detail, and I'm going to go back to our first region just to show an example. That other view here show you the detail of the most important top variables in the model, like groundwater balance and surface water balance, different things like the energy demand. And if you see a little arrow and you click on it, that would mean that it's the different children variables in your model that are used to compute that top variable you were looking at before. And you can see when you displace the mouse exactly what the figure represents, and if you click on this arrow, you can go back, the return arrow, you can go back to the top variables. So that allows you to actually check exactly. For example, for emission, because you apply these policies to reduce emission, you can see a good reduction in your total emission. It is likely that these policies were not about non-ETS emissions, because you see non-ETS emissions are not really changing. Note that when there is this ring, when there's a little thing at the bottom which is black, it means that overall it has gone down. If it was at the top, the sign would mean that the values have gone up. Now, let's look at this view. This represents the whole model. All the variables in your model, they're represented in a hierarchical view. The leftmost node are the top variables you are interested in, and the children node linked to it are the intermediate variables used to compute these top variables on the left. Now, what's interesting is if you select a particular policy, let's say an energy policy of some sort using photovoltaic solar electricity, you left click on this card, this policy card, and then you can see in blue which variables are directly impacted in your model by these policies. And you can see that, for example, there is in the case of water, you can see that there is some sort of impact, and if I click on the gray node, it will show that solar has an impact on cooling water and other things such as groundwater balance, and you can also see that electricity demand is impacted by that particular solar thing by if you look into agricultural area, you can see it's by pumping water from the wells, and this has an influence. You can right click on any node and you get a graph of how this variable changes through time. So this is good because you can compare for different policies the overall impact on the whole of the nexus. See, for example, this particular policy only has an impact on energy, but if you look at other policies like about food, changing the way you plant your crops, let's say agricultural production, then it seems to have a massive impact on the whole of the nexus. So you can compare things and analyze things a little bit better. So I think that's pretty much it. You will have to find different combinations of policies that you can apply to different regions. and you will then be able, when you arrive at the end of your run, to see your final score and see how things have gone up and down. It is suggested, if you really want to make full use of the game, that you open 2 tabs. So let's say you right-click on that tab at the top, and you duplicate that tab. So what will happen, and it will open a new instance of the game, so you can play the 2 instances in parallel. And what becomes useful is that you could just run the game without applying any policy until the end. So you press next turn until you're in 2050, when you receive your final message. And then when you go back to the first tab, you apply policies, and you can then go between the 2 tabs to see the comparison, see how well you're doing compared to the, compared to the business as usual case. So you get, it's kind of easier to see the difference. So I'm going to click until the end, until 2050, and you will see the normal way things to go on and off. And you see it doesn't make a huge difference when you apply policies, because this is a model inspired a bit by real life. You don't multiply or divide your emission by 200% just by applying a policy. You will see a variation which is not that huge, particularly for domains like water, where changing massively crops would change your water health by perhaps 2%, but you're not going to change it by 50%, because water depends strongly on things like rainfall and climate and drought and this kind of things. So for example, here you could see where we had gone in the business as usual kind of case. If we are here, we have started to apply some policy, and we are in 2035, and your health climate score is 53.89. So what happens for the whole of Greece, if I want to look at the health for the whole of Greece? 53.27. So let's say, well, without applying anything, in 2035, if you applied policy, your health for climate is 53.27, and if you here it's 50.34. So there's a 3%-ish difference by applying policies or not, which is a kind of a massive difference at the scale of a country, but do not expect to see absolutely huge difference of like 60 or 70% just because you apply policies. You will see things, maximum usually in the order of 5% kind of difference. Well, that's it really. So it's up to you now to experiment with these combinations of policies and see what happens. Note that when you play the game in the policymaker mode, you will have a limited amount of, you will have a budget of tokens and social acceptance for every single 5 years round. So that means you can only use so many policies. You have a budget limited at the regional level, but also an extra budget that you can spend on at the national level. And you are only allocated so many units per turn. So you would have to do the best with limited resources. So that is all. Thank you very much for listening to me, and I wish you a good game.